Hey guys, so today we're going to look at trigonometric functions of an angle. So I am going to always start by writing my SOHCAHTOA. You will use it pretty much all unit. So starting with sine, this is going to be our opposite. We know that the sine of the degree is 3 over 5. That means our opposite is 3, and our hypotenuse for the SO is 5. Okay, so that means that our x value or our y value is going to be positive. And then one thing you can make a note of here is that your opposite is going to represent the y value. Okay, and that's going to help you place your triangle on the graph. And then if the opposite is the y value, that means that the adjacent is going to be our x value. And knowing positive and negative is going to help a lot. So in this case, our y value is positive. That means that it's going to be up here in quadrant 1 or 2. So then we know that the cosine is less than 0, which means that it's negative. If our cosine, the right, is negative, that means that our adjacent over hypotenuse is equal to a negative number. That means that our adjacent angle has to be negative. Okay, and that also means that our x value is negative. And so that will put us over in this quadrant. So we already knew it was 1 or 2. It'll put us over here since our adjacent has to be negative. So what we know, and of course these don't have to be exact, is that our hypotenuse is 5. Our opposite is 3. And our adjacent down here is negative. Now, typically you should know how to find the a squared plus b squared equals c squared, or know how to use that to find the other side. In this case, we should know that the 3, 5, the other angle has to be 4, but we'll go ahead and just go 9 plus b squared equals 25. So you'll be using Pythagorean theorem on all of these in order to find your missing leg first. Once you find your missing leg, b is equal to positive -4. In this case, for us, it's -4. Okay, once you find your leg, you are just telling me all the trigonometric functions. So we know that sine is 3 over 5. Cosine of the angle, which is adjacent over the hypotenuse, is going to be -4 over 5. And then tangent, which is opposite over adjacent, 3 over -4. All right, and then we have our inverses. We have secant, which goes with cosine, so that'll be the opposite, -5 over 4. Our cosecant goes with sine, is opposite of the sine, so it'd be 5 over 3. And then we have cotangent, which is opposite of tangent, which will be -4 over 3. All right, and that's everything for the first one. So let's look at the second one. I think the most thing you have to worry about is where on the graph it goes, and then just being able to find your third leg. And then after you're able to do that, you can just plug everything else in. So our sine, our opposite over the hypotenuse, is positive, okay? And we have all positive values here. So that tells me that my x is positive and my y is positive, and my graph is going to be somewhere over this way. All right. For cosine, we use our adjacent over hypotenuse. So we know that the hypotenuse is 6. The adjacent is going to be the square root of 3. And we'll use Pythagorean theorem. So we have the square root of 3 squared plus b squared equals 6 squared. So 3 plus b squared equals 36. Move this 3 over. So b squared is equal to 33, and that means b is equal to the square root of 33. And we're going to leave it just like that. So we now know that our missing leg is the square root of 33. Okay, now we're just rewriting all of our trigonometric functions. We already have cosine, so we can know that our secant is the opposite of cosine. 6 over the square root of 3, and we're not gonna worry about radicals. We're just gonna leave it just like this. Next we have sine, opposite over hypotenuse, square root of 33 over 6. Tangent, opposite over adjacent, square root of 33 over the square root of 3, which is just the square root of 11. All right, cotangent is the opposite. So it'll be 1 over the square root of 11 because, you know, the square root of 11 is technically anything over 1. All right, so then we would just flip it. And then I think we're missing one more, cosecant, which is opposite of sine, and that will be 6 over the square root of 33. All right, and then our last one. Our sine is less than 0, so we know that the opposite over hypotenuse. Your hypotenuse is always going to be positive, so it looks like our opposite will be negative here. All right, for tangent, that's opposite over adjacent. Okay, so our opposite is negative, but our adjacent is positive. So what I've written up here, adjacent is x value. All right, so our adjacent puts us over here with the x values, positive x values, but our opposite makes us negative. So we will be down here. So we have negative y values, but positive x values. All right. Here is where our angle will be. So we have our opposite and our adjacent. So our adjacent is 2. And our opposite is the negative square root of 3. All right, so we'll go ahead and do Pythagorean theorem. 2 squared is 4, plus the negative square root of 3 squared is just going to be a positive 3 is equal to c squared, which gives us 7. So square root of 7 is equal to c. So our hypotenuse will just be the square root of 7. Perfect, and now we're just writing our trigonometric functions. So we already have tangent. We can go ahead and write cotangent since it's just the opposite. And we can just leave the negative on top over the square root of 3. Then we have sine, opposite over hypotenuse. That's negative square root of 3 over square root of 7. We're going to leave it just like that. And then our cosecant, which is the opposite of sine, will just be square root of 7 over negative square roots of 3. And then we have cosine, which is going to be adjacent over hypotenuse, 2 over the square root of 7. And then we have secant, which will just be the square root of 7 over 2. All right, and that is the basics of trigonometric functions.